Y'all, so first of all, just kind of check back here. Looks like everything's safe. We are good to go. Okay, so 6-2 and 6-3 parallelograms. Okay, so a parallelogram, all right, is a quadrilateral, which means it has four sides. Okay, that's all a quadrilateral means, and with both pairs of opposite sides parallel. Okay, that's it. That's the only requirement. Okay, so I have both of my opposite sides parallel, and if I have four sides, it is a parallelogram. So as we can see here, right, here is an example of a parallelogram. Now, as a reminder, the matching number of arrows means that they're parallel. So we can see that this side and this side are parallel, and then similarly, this side and this side are parallel. That's what makes it a parallelogram. Okay, now it could be, slanted differently, or it may even look something like a square or a rectangle, right? Because those end up being parallelograms. Now, typically you just see it with these slants, okay? And we'll kind of get into the relationship with, between squares and rectangles and parallelograms another time, okay? So one thing I do want to mention too is that you may see this symbol, okay? You may see that little slanted, again, kind of like a slanted rectangle sort of looking thing. And if it says that, then that means it's essentially labeling it as a parallelogram. And in this case, it's ABCD. Okay, so next little card here. Okay, properties of parallelograms. So we're going to go over a few properties of parallelograms, and we're just going to talk about each one. So the first property, the opposite sides are congruent. So now, not only do we know that the opposite sides are parallel, right? Parallel, never intersecting, right? They've got that same slope. But we also know that the opposite sides are congruent. So that's why I have the tick marks here, right? That's why I have the little tick marks. So I've got this side is congruent to this side, right? It could be like 8 and 8 or something like that. And then this could be like 2 and 2. So similarly, these two are also the same. Cool. The opposite sides are always congruent. So if I know it's a parallelogram, I know my opposite sides are congruent. Next property. Okay, consecutive angles are supplementary. Okay, the consecutive angles. So that is essentially one right after the other, right? Consecutive means one right after the other. So for my example on this one, right, if we just look at the top one, okay, X and Y, those are consecutive, right? So, one is right after the other and vice versa. Now, could we also have, like, down here being consecutive, like, right, these two? Well, the answer is yes. You could also have those consecutive. Could you have these two consecutive? Yes. Those are also consecutive. And then similarly, these two would be consecutive. So it's just right next to each other, right? One right after the other if you're going clockwise or counterclockwise around the shape. Okay, so I gave another example, right? Like X and Y, those are consecutive, but also X and Y here are consecutive. So regardless, they are supplementary. Okay, remember supplementary means that they add up to 180. So here is my picture here. We've got X plus Y does equal 180 degrees. Okay, cool. And just note, right, that in each of these, right, I could write my arrows, right, because we know, I'm telling you it's a parallelogram, right? We know the shape is a parallelogram. I could have my arrows here, but I didn't want to write the arrows to overly confuse you. I just wanted to focus on the exact property that I'm referring to. Okay, and similarly, right, I could have done that as well. Like I could have put the parallel lines here, but it gets too congested if that's the case. All right, so again, these are parallelograms, and since it's a parallelogram, I know my consecutive angles are supplementary. Cool, that's another card. All right, next property, the opposite angles are congruent. Okay, the opposite angles. So here's what's going on here, right? Y and Y, they're directly across from one another. Okay, they are across from one another, right? They're not consecutive, okay? They are across from one another. So since they're across from one another and they are opposite, right, they are congruent, okay? So across from one another or opposite, if we know it's a parallelogram, then those angles are congruent, okay? Similarly, up here, right? So X and X on that particular one, okay? And if you notice, I also put the rings in here, right? I've got one ring, which means those are the same, and then two rings and two rings, which means those are the same. Cool. So my opposite angle, if I know a shape is a parallelogram, then my opposite angles are congruent. Okay, a little bit of a break here. Let's talk about this word diagonal. Okay, we need to talk about this word diagonal. Now, in the context of parallelograms, diagonal does not mean slanted, okay? Yes, parallelograms have slanted lines. And yes, diagonal, right, typically, right, you're either walking like straight or you could be walking diagonal, okay? Right, like we understand what that means in a different context. But this is, in geometry, diagonal means the following. So, a diagonal line is a line that connects vertices that were not previously connected in the shape. So, here's what we have. If we look at this shape right here, here's my parallelogram. Okay, now this is not just in the context of parallelograms. Let me just say that, but since it is, we're talking about parallelograms today, I'm putting it into the context of a parallelogram using the definition of diagonal. Okay, so I've got a parallelogram. All right, the diagonal, okay, again, the vertices that were not already connected. So I have my parallelogram right here. Okay, ABCD is a parallelogram. Okay, and the diagonals are the ones that are like AC, okay, and I put them in little dashes here just to show you like that they weren't previously connected, right? So it's like I have the parallelogram, and if I just draw the lines of the parallelogram, it's those ones that weren't already connected. So I could connect these to these, or I could connect D to B. Now I'm not saying you're always going to see it as little dashed lines, but sometimes you will, okay? And just keep in mind, right, if we're just talking about only the parallelogram, we're connecting those opposite vertices, or in other words, the ones that weren't previously connected when we just drew the shape. Okay, so AC and DB, I should say DB, are diagonals. Okay, so AC, A connecting to C, and then D connecting to B, those are diagonals. Cool, so we're going to need that definition on this next one. Okay, so back to some properties of parallelograms. So the diagonals of a parallelogram, now you know why we're talking about that word. Okay, but the diagonals of a parallelogram bisect each other. Okay, so I had my parallelogram, right? Here's the shape, right? It's these ones on the outside, and the diagonals, like we said, would be here and here. Okay, well, the diagonals happen to bisect each other. Remember what bisect means? Bisect means to split in half. So if I have a line here, it's saying that this line splits the other line, and it's also saying that this line splits the other line. So you end up with a bunch of equal parts, and the parts are here and here are the same, right? These two segments are the same, and then these two segments are the same, okay? Because they split each other in half, right? So this diagonal is now split in half, and then this diagonal is now split in half by the other diagonal. Okay. And the last one, this one's not as common if I'm being completely honest, but the diagonals of a parallelogram split the shape into two congruent triangles. Cool. So I had a parallelogram, one diagonal, right? You now know that these two triangles are the same, and then the other parallelogram, a diagonal, and you know that these two triangles are the same. So you may see that one every once in a while, but probably not as common as the others. The others are a little more applicable. Okay? So those are the properties of a parallelogram and the definition of a parallelogram, and then also the definition of a diagonal. Okay? So let's go ahead and get to the examples. All right? So 6-2 and 6-3. The following quadrilateral is a parallelogram. Solve x and solve y. Cool. Okay, so we got a couple different things going on here. Okay? We could do pretty much either first. Does not matter. I'm going to go ahead and pick y first. No real reason. Okay, so I'm noticing 8y is here. So I know that this length, okay, and it's referring to the length here. I know that this length is 8y. Okay, and let's look at all my other lengths. Well, my other lengths that I know are 88. So let's kind of run through my properties. Okay, and I'm looking at my cards, right? Maybe you took some notes to the side, and you're looking at all your properties of parallelograms. Well, okay, the opposite sides are congruent. Boom. Like that, it gives it to us immediately, right? So you're running through your kind of mental list of options, right? You got opposite sides are congruent, you've got consecutive angles are supplementary, you've got opposite angles are congruent, and you've got the diagonals bisect each other, and you've got the diagonals split the shape into two congruent triangles. Okay? You have all those properties, so you've got to kind of pick which one is the most applicable here. Okay? And it is going to be that property where the opposite sides are congruent. Okay, if I know it's a parallelogram, then my opposite sides are congruent. So I'm using this first property, the first one we learned, the opposite sides are congruent. for example, right? Boom, boom. That's why we have this right here, boom, boom. Okay? Well, what does that mean about y? That means that 8y is equal to 88. Okay, maybe you make a note or something and say opposite sides congruent, something like that. If you need the reasoning, right? We know this because my opposite sides are congruent because of the parallelogram. Okay, therefore 8 times y is equal to 88. So now I'm trying to solve for y. Well, it means I want to get rid of the 8. So if I want to undo that, I'm going to divide both sides by 8. Therefore y is 11. Okay, now maybe the algebra is more complicated. Depends on the problem. Okay, but the property still applies, right? You've got opposite sides are congruent. Cool. That is y. So we also have to find x. Okay, so looking at x, here it is. Okay, it's an angle. Okay, so we got to find a way to talk about the relationships with my angles in the parallelogram. So let's go ahead and look at it. Okay, I've got the consecutive angles are supplementary. Okay, so I've got 6x and I've got the 90 degrees. Okay, so 6x and that 90 degrees, those are not consecutive, right? They're not one after the other, right? One connecting, right? One after the other if I'm going clockwise or counterclockwise around my angles. Okay, these are not consecutive. So that property doesn't apply. Not going to use that one. But I do know my opposite angles are congruent. Okay, 6x and 90, those are opposite. And if I know my opposite angles are congruent, I can go ahead and say that 6x is equal to 90. So let's go ahead and write that relationship. So 6x is equal to 90. Okay, if you need some justification or something, right? Opposite angles are congruent. Boom. That's the property that we learned earlier, and that is the property we're using here. So 6x is equal to 90. Again, the algebra on this one, not particularly difficult. Okay, it's a one-step algebra problem. Maybe the algebra is more complicated. Maybe it's a two-step, three-step, whatever it is. You can set these two things equal to each other because we know that they're the same, because we know it's a parallelogram. Okay, so I've got 6x is equal to 90. So I'm going to divide both sides by 6 here. So I've got x is equal to 90 divided by 6. Okay, maybe we know that in our heads, maybe we don't. But the way I would personally think about this is I would go to the 60. 60 divided by 6. Okay, 60 divided by 6. That's going to be 10. Okay, and I have 30 left between the 60 and the 90. Okay, so 30 divided by 6, that's going to be 5. So I can now split that, and which will give me 15. Okay, so x is going to be 15. Maybe I should write x is 15. As opposed to just boxing the 15. Okay, cool. There's that one. All right, number 2. Okay, the following quadrilateral is a parallelogram, solve x and y. So similar steps, okay, similar steps, but now we got to find a different relationship, okay? So I'm looking at this one, okay, and I notice, me personally, that I've got an x here and I've got an x here, okay? So if I notice something's the same, right, I'm always going to look for a relationship, right? We have to find a relationship between something that we know, like we got to know some things for sure, right? If I need to know some things about x, but then I need to know what those are equal to on the other side of the equation, right? So on this particular one, I notice that 6x and 12x are consecutive, right? There's one right after the other, right? It's if I'm counting or something, 1, 2, 3, 4, right? 2 and 3. Those are two numbers back to back, right? If I'm going in an order around, or if I were to go this way around in the shape. So I've got 6x and 12x. Well, what is my property about consecutive angles in a parallelogram? Well, again, if I'm using my notes, I have that consecutive angles are supplementary. And what does supplementary mean? It means 180. Right? It means they add up to 180. Okay? So in order to solve x, I can go ahead and say that 6x plus 12x is equal to 180. So that is my property. Now, I do want to mention here, let's go ahead and label my sides as parallel, right? Because we do know that it's a parallelogram, okay? This should remind you of something a little bit. If I were to cover the top, okay, a while back in our class, we went over parallel lines and transversals. If you remember that, you should see a little bit of a pattern, right? You should see a little bit of a connection, right? So this could be like my transversal, right? And that's my parallel lines. Well, these are like consecutive interior angles. Okay, so it even uses that same word, right? Consecutive. So these are also, one way to think about it is that these are consecutive interior angles. Okay, so I just wanted to point that out. There's a little connection between what we did before. Okay, but let's say we don't remember that and we're just using the properties that we learned today, then that's perfectly fine, right? So we've got 6x plus 12x is equal to 180. In both cases, they'll be equal to 180. So even if you took the other route, you should get the same answer. So maybe I write down my reason like I've been doing: consecutive angles add up to 180. Okay, maybe I've got something like that. There's my reason. Now I'm doing my algebra. Okay, and what I notice is I've got 6x here and I've got a 12x here. So these are like terms. Okay, these are like terms, right? This is one term, right? I'm multiplying, so that's what gives it. That's what makes it the term, right? And it's also separated by a plus sign. That's also what kind of makes it a term. So anyways, I've got 6x and I've got 12x. Therefore, those two add up to 18x. Okay, and then equals 180. Now I just divide by 18 because I'm trying to just get that x by itself. And we're dividing by 18 because what were we doing before? We were multiplying, right? If it's right next to each other, 18 times x. We don't say that a whole lot, but this is 18 times x. Okay, again, 18 times x. So in order to get rid of that 18, I will do the opposite, which is divide. So I end up with x is equal to, if you were to put that in your calculator or just know that, that is x is equal to 10. All right, cool. So on this next one, okay, you've got some options, okay? Looking at y. Here's y. Here's y, okay? Now, like I said, two different options here, okay? Let's look at the other two pieces that we now know, okay? And let's label them, right? So we know that this is 12x, therefore it's 12 times 10, right? Because we now know that x is 10. So this angle is actually 120 degrees, okay? This one right here is now 60 degrees, okay? So you've got some options, okay, with y. Because if I notice this, well, I should say 3y, right? This whole angle is 3y. And I'm looking at it, and I see that 3y, right, that's consecutive with this one. Okay, so these two are consecutive, right? If I were to cover it, okay, consecutive interior angles, there it is. Okay, so I've got the 3y and the 6x, those are consecutive. But in my opinion, it's a little bit easier to say two things are equal than it is to say that they're supplementary. So if I'm looking at these two, I notice that these are opposite angles in my parallelogram. Okay, therefore, 3y has to be 120. Okay, because that's, again, one of my properties. What do I know about opposite angles? Well, I know that my opposite angles are congruent. So y and y, there you can see it, right? These two are the same. Similarly, these two are the same. Okay, so that's what we have. So we can go ahead and say that 3y is equal to 120. 3y is equal to 120. Our last step, divide by 3, divide by 3, divide by 3. Okay, so y is equal to 40. And we have number 2. Okay, now, to be consistent here, right, we could write opposite angles congruent. Okay, my opposite angles are congruent. Cool. Last question. Okay, the following quadrilateral is a parallelogram. Solve for x and y. All right, what do I know about this problem? Well, if we were to just kind of write it plainly, just as a quick sketch, ooh, that was awful. But you get the point. It should be a parallelogram. Man, that was bad. Oh well. And so we got parallel lines here and here, and then parallel lines here and here, right? Notice I have my diagonals. Okay, these are my diagonals right there and right there. So, what do I know about the diagonals in a parallelogram? Well, the first thing is I got these two right here. Okay, well, the first thing I wrote down was the diagonals of a parallelogram bisect each other. That's my winner, okay? You could look at this property. That's not going to help you. The other property of a diagonal in a parallelogram. But if we're looking at this one, I end up with two sections that are the same. So this and this are the same. Okay, these two right here are the same. And then these two right here are the same. Okay, now yes, this is a little bit backwards than what we had like right here. Okay, but they're both parallelograms. Okay, so we've got to be able to kind of twist it around in our mind. But essentially, you end up with this and this are the same, and you end up with this and this are the same. That's the whole bisecting part of it, right? They split each other in half, kind of like what we were saying before. Okay, so now that I have my tick marks, now that I've labeled the information, right, I've applied this property, it actually becomes just another algebra problem. Okay, because now that I know that this 12 and this 3x are the same, I can say that 3x is equal to 12. Again, because of the tick mark. That's why I put that visual marker on there, because now I see it, and it makes it easier for my brain to understand that they're the same. Okay, so I've got 3x and 12, and then I see that the 4y and the 8, okay, I just set those two different sets equal to each other. Now you've got your one-step algebra problem. Again, could it be more complicated algebra? Sure, it could be, but in this particular one, it's not. Okay, so we've got 3 times x equals 12. We'll divide by 3, x is 4, okay, and dividing by 4 here, y is 2. And that is it. That is it. That is applying those, I guess, 5 different properties of parallelograms. Okay? Hope you guys have a great day. Take care.